Okay, so let's just remind ourselves of all of the forms that we have learned for derivatives. We know that the derivative of a constant is, you got it, 0. We know that the derivative of a linear function, ax plus b, is a. We know that the derivative of x to the power of n is
nx to the power of n minus 1.
You got it, that's our power rule. Then last class we learned some new derivatives. We learned that the derivative of e to the x, anyone remember?
E to the x again.
E to the x, and then we learned the derivative of a to the x, that it's a little bit different.
A to the x ln.
You got it, a to the x ln a. And then we learned the derivative of natural log x was?
Log, no, ln. It's either that or e, I don't know. Okay.
It is 1 over x, actually.
Oh, so true.
Yeah, so it's 1 over x, and who remembers what the base of ln is? It's log base
E.
E, you got it, Claudia. So log base E, and then log base A of x, how does that change things? It doesn't change things. It does change things.
It's 1 over x ln a.
You got it. It's just that we have that extra ln a down there in the same way that we had the extra ln a when our base was a for the exponent. All right, so these are like simple rules. We can look at these things, we can just immediately know the derivative. So today we're going to learn 2 rules called the product rule and the quotient rule. So the first thing that I want us to remember that we saw in class last time is that if I have 2 functions multiplied together, the derivative of that does not equal to the derivative of the first times the derivative of the second. We actually have a special rule for dealing with products, and we can prove this rule using the limit definition of the derivative. Good news, I'm not going to. I'm just going to tell it to you, and you're going to believe me. And if you don't want to believe me and you want to see the proof, come to my office hours and I'm happy to go through it with you. So if I have 2 functions being multiplied together, the product rule tells me that I can do the derivative of the first times the second plus the first times the derivative of the second. Or if we were to use our other notation, then we'll have the derivative of f of x, so the derivative of the first times the second plus the first times the derivative of the second. So this is the product rule, heretofore known as PR. Let us apply the product rule. Okay, so we're going to start with a question that we did yesterday, and I'm going to do it in 2 different ways. So yesterday we did the derivative of f of x is equal to x times the square root of x. And I just want to remind you that the first thing that we did here is we rewrote that square root of x as x to the power of 1/2. So now I'm going to do this in the same way we did it yesterday, just to kind of remind us of how that worked. And then I'm going to do it with the product rule, this new rule that we had learned. So without the product rule, I saw that I can simplify this, that I had two things being multiplied together, and that when I do that, I can add the exponents to have that this is x to the 3/2. So then I can just apply my simple power rule. So then with the product rule, are there any questions about this brief review that we just did of yesterday? Good. So then with the product rule, I can see that I have two things being multiplied together. I can see that I could rewrite this as x times x to the 1/2. And the fact that I have that word times in the middle there, that tells me that a product rule is a good idea. And I can identify these as the f and the g from my product rule. So I'm going to use some interesting notation here. To do f prime of x, the product rule tells me the derivative of the first times the second plus the first times the derivative of the second. So I'm going to stick this in here exactly as they are. I'm not going to take any derivatives. I'm just going to stick it into the product rule. So I'm going to do the derivative of the first times the second plus the first times the derivative of the second. So then notice this has a prime on it and this has a prime on it. So these things that I've just highlighted are like placeholders for derivatives to come. It says, I still have to take the derivative of that. And this is like my f prime g plus f g prime that I just stuck in to the formula for the product rule. So then f prime of x is equal to, what's the derivative of x? You got it, 1. Times x to the 1/2 plus x, what's the derivative of x to the 1/2?
1/2 x to the power of -1/2.
You got it. I'm bringing that 1/2 down and I'm subtracting 1. I'm just applying my simple power rule to that. So that's 1/2 x to the -1/2. So at this point, this looks a lot different than that 3/2 x to the 1/2 that I got over there. But I'm going to show you that it's actually the same thing. Here we have a rule that says I can add my exponents. So this is actually going to be x to the power of 1 minus 1/2. So this is x to the 1/2 plus 1/2 x to the 1/2, which gives me 3/2 x to the 1/2, and I ended up with the same answer. So did I need a product rule here? No. And in this case, the product rule was probably a little bit bulkier than the other way. The other way was probably a little bit easier because it was really simple to just simplify that thing. So we're going to do another problem where I don't need the product rule, and then we're going to do one where I actually have to use the product rule. So for B here, we will have g of x is equal to 1/x plus 1 times the square root of x plus 2. Do I have two things being multiplied together here?
Yep.
Yes. So I actually have two options here. My first option is to do what we learned how to do on Monday, to simplify this thing. So on Monday, we learned that we can expand and use algebra rules to simplify to simple power rules. So we're gonna, option 1 would be to expand and simplify to apply the power rule. And my option 2 is to not do that and to just immediately apply the product rule. And we're going to go with option 2. And so we're going to identify that that's F and that's G. So I'm going to do the same thing here that I did in that last question. I'm just going to stick these into the formula for the product rule. But while I'm doing that, I'm going to rewrite these things in a simpler form. How can I write 1 over x as x to a power?
X to the power minus 1.
You got it, x to the minus 1. So I'm doing the product rule says the derivative of the first, so I put a prime there, times the second, the square root of x is x to the 1/2, plus the first times the derivative of the second. So the second one gets my prime there. And notice both of these things, when I stuck them into the product rule, those are the things I have to take the derivative of. So those are the derivatives to come. That prime is the placeholder. It's saying you still have to do the derivative of this thing. But now this derivative has turned into a simple power rule. So g prime of x is equal to, what's the derivative of x to the negative 1 plus 1?
Minus x to the power minus 2.
You got it, minus x to the minus 2. I just applied my power rule. I brought the power down and I subtracted 1. Then notice, x to the 1/2 plus 2 does not have a prime, so I don't change it. X to the negative 1 plus 1 does not have a prime, so I don't change it. But x to the 1/2 plus 2 does. So I take my derivative, that's my answer. Are there any questions about that? Okay, so in both of the problems we've done so far, we didn't actually have to use a product rule. So let's do one where we do have to use a product rule. So here I have f of x is equal to x e to the x. Could I insert the word times between x and e to the x?
Yeah.
Yeah.
Yeah, so I could say that this is x times e to the x. The fact that I can stick the word times in there tells me that this is a product rule. And there's no simplification I can do here because of that e to the x. I can't like combine these things. There are no rules that allow me to simplify this. So instead I just identify my f, I identify my g, and I stick it into the product rule. So I have the derivative of the first times the second plus the first times the derivative of the second. And so the things that are primed, those are the derivatives that I still have to do. What's the derivative of x?
1.
You got it. So this is 1 times e to the x plus x. What's the derivative of e to the x?
E to the x.
You got it. So these are just the rules that we reminded ourselves of at the beginning of class, these derivative rules here. So from now on, we're always going to be applying those derivative rules. So then this is just e to the x plus x e to the x, and that is my final answer. And there I had no choice. I had to do a product rule. Are there any questions about that problem?
Can you go up a bit?
Yes. How's that?
That's good.
All right. I'm gonna go grab some water and give you guys a second to catch up to me and make sure you don't have any questions. Okay. Are there any questions? Good. So then let's move on to D. So we're going to do another one that actually requires the product rule. G of x is equal to 2 to the x ln x. So even though I didn't say times, could I insert the word times between those two things?
Yep.
2 to the x times ln x. So this is 2 to the x times ln x. Again, that times, the fact that I can put that word there is a clue that the product rule is a good plan. So I identify my f, and I identify my g, and I just immediately plug it in to the formula for the product rule. So the derivative of the first times the second plus the first times the derivative of the second. And those primes are placeholders for derivatives that I still have to take. What's the derivative of 2 to the x?
It's 2 to the x ln 2.
You got it, 2 to the x ln 2. Can I go back up for a second? That's our a to the x rule that we saw yesterday. So 2 to the x, so that's a to the x ln a. That gives me 2 to the x ln 2, which I am then multiplying by ln x plus 2 to the x that didn't get touched. What's the derivative of ln x?
1 over x now?
1 over x. And guess what? I'm done. That's my answer. Okay, we're going to do one that's a little bit different than this now, but that still involves a product rule. That's going to remind us again of some of the things that we did yesterday. So let's say that I have h of x is equal to the cubed root of x plus x to the 5th e to the x plus x squared ln x all over the square root of x. Who remembers what we do in the situation where we have something like this, where we have a quotient that looks like that?
You put all of them individually over the square root of x.
Exactly, Luca. Good job. So the fact that we have this one term on the bottom and those multiple terms on top tells me that I can put each of them individually over the square root of x. So this is a thing that we saw yesterday for if we have something like this, and that also actually appeared in your last web work. So I'm going to rewrite this as I do that. The cubed root of x is x to the 1/3. The square root of x is x to the 1/2. Now I want you guys to be careful about this part. I only distribute to pluses so that x to the 5th e to the x only gets 1 square root of x. I don't have a separate one for the x to the 5th and for the e to the x. It only gets 1. We're only separating at addition. So then this is plus x squared ln x over x to the 1/2. And so now I'm just going to remind us of the algebra rule that we're going to use here. X to the a over x to the b is equal to x to the a minus b. And so I can actually simplify, even though that e to the x and that ln x are there, it's not going to change the fact that I can simplify those x's. So I'll have x to the 1/3 minus 1/2, x to the 5 minus 1/2, x to the 2 minus 1/2. And I'm simplifying each of those things in the same way that we were doing in the last two classes. So this will give me x to the 1/3 minus 1/2, that's x to the negative 1/6, plus x to the 5 minus 1/2, that's x to the 9/2, e to the x, plus x to the 2 minus 1/2, that's x to the 3/2 ln x. So I know that was a lot of algebra that we just did there. Are there any questions? Do you guys follow how we got each of the separate things?
Yeah.
So far, so good? All right. Okay. How many terms do I have here?
3.
3. Have I taken any derivatives yet?
No.
No, this is just entirely simplified. So this is my simplified form. And I have 3 terms, because remember, a term is a thing separated by addition or subtraction. I'm going to use that word a lot this semester. You should get comfortable with what a term means. Term, separated by addition or subtraction. Okay, so this is my first term, this is my second term, this is my third term. I have 3 terms. Do any of them require the product rule?
The second and third.
The second and third. Good job, Michael. So the second and third ones have products. This is a product, so this is going to require a product rule. This is a product. This is going to require a product rule. I have an F and I have a G in each of them. What rule am I going to use for the x to the negative 1/6?
Just the exponent rule?
Just my simple power rule. You got it. Power rule. So now, when I take the derivative, I'm going to do the same thing that I was doing in the last problems. For the product rule, I'm just going to stick the things in. So first I bring my 1/6 down, and I subtract 1 to get negative 7/6. So I'm bringing the negative 1/6 down, and I'm subtracting 1. Then I'm going to plug in to my product rule. The derivative of the first times the second, plus the first times the derivative of the second, plus the derivative of the first times the second, plus the first times the derivative of the second. And that leaves me with 4 derivatives left to take. This was my product rule for the second term. This was my product rule for the third term. And now I finish by taking the derivatives of the things that I've highlighted there that still have those primes on them. Nothing else changes. That's a power rule. The derivative of e to the x is just e to the x. I have another power rule. And the derivative of ln x is 1 over x. So here I just applied my power rules. And then for the e to the x and the ln x, I applied the appropriate rule. And that's my final answer. So notice sometimes we might have a problem that involves a lot of simplification, but that still requires a product rule when we are done. Are there any questions about what I did here? All right, so I'm gonna give you guys about 3 minutes to do the next problem. That's gonna be a lot simpler. I just wanna see you guys make sure that you got this product rule down before we learn the next rule. So I want you guys to take the derivative of p of x is equal to 2x squared minus log base 4 of x times e to the x plus 6 to the x. When you are done, I'm going to give you 3 to 4 minutes. In the chat, write your answer. So privately or not, I guess it doesn't matter. Just send me a chat message with your answer.
So when we're done, we write it in the chat.
Yeah, just send me a message in the chat with your answer.
Okay.
It can be private, that's fine. Are you guys getting it?
Yeah, it just takes a while to type.
Yeah, it definitely takes a while to type.
Like, how am I gonna do the symbol for like the derivative of, like, you know, I have my bracket and then I have my like comma kind of.
Yeah, your prime?
How would I type that?
You mean like this?
Yeah, yeah.
You just do an apostrophe.
Okay, okay.
So it looks like you didn't apply the product rule. It looks like you did the derivative of the first times the derivative of the second. So it looks to me like the answer that you just sent, You did the derivative of this times the derivative of this. What's the product rule though? This is a product, so we actually have to apply the product rule. So you did f prime g prime. I want to see f prime g plus f g prime. And then that looks great, Luca. David, that looks good. And then you'll do the derivative of the parts you primed. Matt, that looks good. Sam, that looks good. All right, we're getting some answers here. Okay, so I'm going to write the first step because a couple of you seem to have done f prime g prime. So I'm going to just write this. I'm going to separate it with the primes. I'm doing the derivative of the first. So that's primed times the second plus the first Michael, that looks good. Times the derivative of the second. So for those of you that did f prime g prime, you did the f prime and the g prime correctly, but where do they go? They go into the product rule. All right, so it looks like most of you that are answering are getting it, so great job. I'm just gonna write the answer here. Is this what you guys were getting? Are there any questions about this answer right here? Any questions about the product rule in general? Good job, Cam. Awesome. Okay, so that's the product rule. Are y'all ready to learn a new rule? The quotient rule. So the same with the product rule. We said we can't do f prime g prime. With the quotient, if I have f over g and I want the derivative of that, it does not equal 2f prime over g prime. So in the same way that we had a special rule for products, we have a special rule for quotients. And that rule is f prime of x times g of x minus f of x times g prime of x all over g of x squared. Or if we use our other notation, ddx of f of x over g of x is the derivative of f of x times g of x minus f of x times the derivative of g of x all over g of x squared. So I want you to notice that the numerator of this thing, f prime g minus f g prime, is the same thing as the product rule, but with a minus in the middle.
And the division.
Well, yeah, I'm just saying just the numerator, if you just look at the numerator. But then we also have that division by g squared. So this is our quotient rule, heretofore known as QR. It's okay. And this is yet another rule that you're gonna need to memorize. Let's see this rule in action. All right, so we have our quotient rule. Let's do some derivatives. Is this a quotient?
Yeah.
Yep, which means I'm gonna apply my quotient rule. It's actually a lot easier to see that you definitely have to use a quotient rule than a product rule. It's much easier to accidentally not use a product rule than it is to accidentally not use a quotient rule. So that's my F, that's my G. I'm gonna do this in the same way I did the product rule. I'm gonna take these things and I'm not gonna actually take any derivatives. I'm just going to stick them in the formula with primes. So F prime, that's the top. So the derivative of the top, so that has a prime, times the bottom, minus the top, times the derivative of the bottom, all divided by the bottom squared. So the things that had primes, that was my F prime and my G prime, those are the derivatives that I now have to take. So first I stuck things in the quotient rule. Now I'm going to take those derivatives. So F prime of x is equal to, what's the derivative of x squared minus 3x plus 4?
2x minus 3.
Ta-da, 2x minus 3. There was no prime on the x cubed plus x, so I don't touch it. There was no prime on this x squared minus 3x plus 4, so I don't touch it. What's the derivative of x cubed plus x?
3x squared plus 1. 3x squared.
And then I divide that by x cubed plus x squared, and that's my final answer.
Shouldn't we? Okay, never mind. But can we factorize x squared minus 3x plus 4?
It doesn't
Like
matter.
if it were.
The answer is that it doesn't matter. So can we factor it? It's x 4, x minus 4 times x plus 1. But that's not going to be helpful in this case.
Okay.
And so typically with the product rule and the quotient rule, we actually are going to learn very specific cases where simplification is going to be helpful. But aside from those cases, it really doesn't make sense to do things like factor or try to simplify. Just stick things as they are. This is an ugly answer. That's okay. This is the answer I'm going to accept. I could make it look prettier, but I'm not going to ask you to, except in very specific cases, which I'll talk to you about later.
Okay.
Okay, so that's our first quotient rule. Are there any questions? Good. So in this next question, let's find a tangent line. So I want to find the equation of the tangent line to f of x is equal to e to the x over x plus 1 at x equals 0. What's the first step in finding the equation of a tangent line?
Find the derivative.
Exactly, we're
Right.
going to find the derivative. And what rule do I need to use to find the derivative here?
Quotient rule.
You got it. I have a quotient. I have to apply the quotient rule. So that's my f, and that's my g. So first we're going to find the derivative, f prime of x, and I'm just going to stick this in. So hopefully you guys are going to get comfortable enough with the product rule and the quotient rule that you don't have to do this intermediary step that I'm doing every single time. But it is useful notation for when things get complicated. So I'm doing the derivative of the top times the bottom minus the top times the derivative of the bottom, all divided by the bottom squared. So I have two primes here, which means that I have two derivatives to take. What's the derivative of e to the x?
E to the x.
Hopefully you guys are starting to like memorize these now. You'll see we do them a lot. So like it feels like you have a lot to memorize, but hopefully you're doing them enough that you don't feel like you're memorizing them. It's just like they're in your head. So e to the x times x plus 1 minus, what's the derivative of x plus 1?
1.
You got it. Over x plus 1 squared. Now what do I do with that derivative?
You plug 1 or 0. Sorry, 0.
Why do I plug in 0? What am I going to find?
You're gonna find the equation of the tangent line at x is equal to 0.
Yes, but plugging in 0 specifically, what piece of information does that give me about that line?
The slope.
The slope. You got it. So really my first step is to find the slope, and we know that in order to find the slope, we have to find the derivative. So now I'm saying slope. So my slope is equal to f prime of 0. So this is e to the 0 times 0 plus 1 minus e to the 0 over 0 plus 1 squared. What does e to the 0 equal?
1.
1.
1. So this is equal to 1 minus 1 over 1, which is 0 over 1. Does that exist?
No.
You guys agree that it doesn't exist?
It does exist.
It does exist. What does it equal?
It could be, does not exist, or it could be infinity or negative infinity.
Are you sure?
Yes.
This weird thing happens. We learn about a constant over 0. And suddenly you guys see 0. And it happens every semester and think infinity.
It's
Is
0.
that 0 in the denominator?
It's 0.
No. So I want you guys to be careful about this. I kind of put that on you. That's my fault. But like the fact is that the 0 in the numerator is okay. This is just 0. Good job, Zach. It's just 0. 0 on top is okay. It's when we have a 0 on the bottom that we have a problem. So this is just 0. So my slope is equal to 0. Now let's not let this scare us. What does this tell me about my tangent line? You got it. It's horizontal. So at this point, some of you might be like, oh my gosh, what are we supposed to do? How do we write the equation of the line? The slope is 0. Don't let this scare you. We're going to follow our steps in exactly the same way that we would typically follow our steps. So our next step is to find the y value. And the y value we get by plugging 0 into the original function, which just gives me a 1. So this gave me my point, which is 0, 1. And that point is important because it's the thing that allows me to solve for b. And I'm going to do this in the same way. I'm going to use a little bit of a weird notation along the way just to kind of make sure that you guys are following. A is 0. My slope is 0. So I'm saying y is equal to 0x plus b. So then I plug in the point. My point is 0, 1. So I get 1 is equal to 0 times 0 plus b. And what does b equal?
1.
1. So then y is equal to 1. That is my tangent line. That is my horizontal tangent line. And we did a quotient rule to find our derivative. Are there any questions about how we found this tangent line or how we used the quotient rule to find the derivative?
How did you get the point?
So the point, we know that the point is on the tangent line. The point is on the tangent line, but it's also on the function. So we use the given x value. So hang on, I'm going to write this down while I say it. So we plug the given x value, which in this case is 0. That's what was given at the beginning, into the original function to find the y value. Does that answer your question, Alex?
Yeah, but I don't know how to like
Think
like,
about
how
it.
yeah, like how did you get 1?
Because e to the 0, so e to the 0 is equal to 1.
Oh,
If I do like an
okay.
intermediary step here, which I will just so that we can see it, this is like saying 1 over 0 plus 1.
Oh, okay. Okay.
And that's just because e to the 0 is equal to 1. Are there any other questions? Okay, so we're going to do one more quotient rule, and then we're going to see these rules combined. So I have a quotient here. I need to use a quotient rule. How many constants do I have here? How many terms do I have that are constants? So in the numerator, for example, I have ln x plus 8 to the x plus pi. How many of those three things are constants?
2.
1. Just the pi, no?
Just the pi. Just the pi is a constant. So pi is a constant. But possibly, David, you were answering the original question. But in the denominator, I have x to the 9 plus log base 6 of 5. So I have two things. How many of those two things are constants?
1.
1. So x to the 9 is not a constant, but is log base 6 of 5 just a constant? That log base 6 of 5, there are no x's involved. This is just a constant. Does that make sense? And do you guys understand now the question that I was asking? Cool. So then we apply this in, we plug this into our quotient rule. We have the derivative of the top times the bottom minus the top times the derivative of the bottom, all divided by the bottom squared. We plugged it into the quotient rule without taking any derivatives, which means we now have two derivatives left to do. We identified the things that were constants. And what's the derivative of a constant?
0.
0. So h prime of x, the derivative of ln x is 1 over x. The derivative of 8 to the x is 8 to the x ln 8. The derivative of pi is 0. So these are just simple derivative rules that hopefully you are in the process of memorizing. X to the 9 plus log base 6 of 5 minus ln x plus 8 to the x plus pi. There wasn't a prime there, so I just write what I have, times the derivative of this, which is 9x to the 8. That second part is a constant. Its derivative is 0. There is no prime on the bottom, so it just stays the same. Log base 6 of 5 squared. Voila. How do you guys feel about the quotient rule? Did I screw something up?
No, I'm just writing it down.
Yeah, I know someone else was making a face.
In the first f prime, wouldn't there be 1 over 8 to the power of x ln 8, or no?
No. So that
Okay.
is, I'm going to go back up and show us the derivatives here. The derivative we're doing here is like the a to the x that I have right there.
Oh, okay, yeah,
Right?
not
So it's
okay.
not a log. So I think you were thinking about the log.
Yeah.
How did you get 9x to the 8?
All right, so let's go look at that. So I'm taking the derivative of the denominator here, that second part. So the first part of it was x to the 9, right? So that's just a power rule. So I'm taking that 9, I'm bringing it down, and I'm subtracting 1.
Okay.
Yeah?
Okay.
Any other questions? All right, y'all ready to combine these things? It's gonna be so fun. All right, okay, so we're gonna do one first example that I'm gonna call f of x
Do we do it now?
Yeah, I'm gonna do it.
Oh.
I'm just waiting for
Okay.
people to make sure that everyone's caught up with me. Okay, so let's go. So when you look at this, what rule do you think is a good rule to start with?
Product rule on the bottom, on the denominator?
product.
So I have a product rule in the denominator for sure. But is that product rule only in the denominator, or is it the whole thing?
Only the bottom.
Only the bottom. The whole thing is a quotient. So what I can see is that the big thing I have a product inside of a quotient. And what that means is that I will have a product rule inside of a quotient rule. And in a second, so the next question I'm going to do is going to be the opposite so that we can see what I mean by that and see how it's going to be different. So I'm going to do this in exactly the same way I've been doing it. I'm going to put this into the formula for the quotient rule without actually taking any derivatives. So my f prime of x is the derivative of the top times the bottom minus the top times the derivative of the bottom, all divided by the bottom squared. So I just applied my quotient rule. And let's look at the things that I have primed here. The first thing I have primed is 2x plus 3. Is that going to require a product rule? No. What's the derivative of 2x plus 3?
2.
2. Then the second thing I have primed is the whole denominator. Is that going to require a product rule?
Yeah.
Yes. So now we see how that product rule showed up inside of my quotient rule. I just did the exact same thing that I was normally doing for my quotient rule, and it just so happened that one of the primes I had is a product. So I'm going to need to apply my product rule. So I'm going to do that now. F prime of x is equal to, we said the derivative of this was 2. So 2 times x minus 2 times 3 to the x plus 6 minus 2x plus 3 times, and I'm going to do this in 2 steps. Now I'm applying my product rule. That's my f, that's my g. So I'm doing the derivative of the first times the second plus the first times the derivative of the second. All over the denominator squared. So far, so good?
Yep.
Let's look at the things I have primed now. X minus 2 prime. Is that going to require a product rule? No, it's already inside of the product rule. So 3 to the x plus 6 and x minus 2, neither of those are product rules. Those are just simple derivatives that we reminded ourselves of at the beginning of class today. Those are just our simple derivative rules we can look at and do the derivative. So now those are the primes that are left. I'm going to take my derivative. What's the derivative of x minus 2?
1.
1. So I have 3 to the x plus 6 plus x minus 2. What's the derivative of 3 to the x plus 6?
3 to the power of x ln 3.
Good job. Okay, I have a question. This power of 2 that I have right here, can I distribute it inside or no? So can I distribute a power inside of an addition? In other words, can I do like x plus, or actually let's do this with a's plus b's. Can I do a plus b to the power of n is equal to a to the n plus b to the n? Are you sure?
No.
I am not allowed to do that. That is not okay. Can't distribute powers in addition, but if I have a times b to the power of n, can I do a to the n times b to the n?
Yes.
Yes. So that 2 right there, I can actually distribute to the inside. So that's what I was doing there. I'm distributing that 2. Now the second thing that I really want to point out here that's important is a product rule has a plus in it. Because of that, these parentheses are important. If you forget them on a test, you might lose half a point. If you forget them,
Can you replace those by parentheses, or do they have to be like brackets?
no, they can be big they can just be big parentheses. I just put them as brackets because I really want to stress that they're there.
Yeah. Well, it's just the multiplication, so
Yeah.
parentheses. Okay. Yeah.
Yes, exactly. So it's just multiplication, but like that 2x plus 3 would be distributed to the inside. So again, like I was saying, if you forget them on a test, you might lose half a point or a point. If you forget them on WebWork, WebWork will tell you you are wrong. And then you will get really frustrated and you won't understand why you're wrong. And you'll be like, but I know I'm doing this right. I did everything perfect. And WebWork will just keep telling you you're wrong. You need those parentheses. Without those parentheses, you're not going to get anywhere. So be careful. Don't forget your parentheses. Are there any questions about how we just did that product rule inside of the quotient rule? Are there any questions about how I distributed that power? Okay, so I'm going to do one more question today. It's going to hopefully help us see the difference between what I was saying with a product rule inside a quotient rule versus a quotient rule inside a product rule. So what's going on here?
We have a product rule that has a quotient rule inside of it.
You got it. So like the big main thing that's happening here is I have two things being multiplied together. Over here, I had two things being divided. I had F being divided by G, and it just so happened that G was a product. And here, I have F times G, and it just so happens that F is a quotient. So here I have a quotient inside a product, which means I'm going to have a quotient rule inside my product rule. But I'm going to do this in the same way. I'm going to be like, I identified my F and G for the product rule. So I have my product rule going on here. And I am just going to immediately stick it in to the formula for the product rule, which tells me the derivative of the first times the second plus the first times the derivative of the second. And now the derivatives that I still have are that 2x plus 3 prime and the e to the x over x prime. And as we noticed in the beginning, when I have my f prime there, it turns out I'm going to need a quotient rule. So that's my f, and that's my g. So then this is going to be two more steps. G prime of x, I've identified my f and g for the quotient rule. So now I'm just going to immediately plug it into the quotient rule formula. The derivative of the top times the bottom minus the top times the derivative of the bottom, all divided by the bottom squared. What's the derivative of 2x plus 3?
2.
Ta-da, 2. Do I have any primes left over that I haven't done yet?
E to the x and x.
E to the x and x. So I still have these two primes that showed up when I plugged things in to my quotient rule. So then my g prime of x is equal to the derivative of e to the x, that's just e to the x. The derivative of x is 1. And that's my final answer. Yes.
I did the second step, like second to third step, just in one go from
Totally
the first one.
fine. I'm
Okay.
hoping that everyone will eventually get there.
All right.
Yeah. So like I actually am going to do one last problem where I just do it in one go and show you guys like what I expect in terms of work from this. But before I do that, I just want to see, I want you guys to look at these two problems together and make sure that you understand the difference between how we figured out what to start with. How the first one I had to start with my quotient rule and the second one I had to start with my product rule. Are there any questions about that? Are you guys ready for a last problem, or have I gotten way too far ahead of you? Please let me know in the chat. All right, then. Let's do this last problem. And so this last problem, I'm just going to do really fast to kind of show you where I hope that you'll eventually get. I'm not going to over-explain things. I'm just going to do it. So if I have f of x is equal to x squared plus 4x plus 1 times 2 to the x plus ln x over x e to the x. Let's say that I have something like this. This is going to be a quotient rule with two product rules. Both f and g need the product rules. So if you go straight to the answer, eventually, hopefully you're going to get there. So I'm just going to write down the answer and let you try to figure out where things came from. I'm going to do the derivative of the top. The derivative of the top is a product rule. So it's the derivative of the first times the second plus the first times the derivative of the second, all in parentheses, times the bottom, minus the top. I hope I'm going to have room here. Times the derivative of the bottom, which is the derivative of the first, times the second, plus the first times the derivative of the second. All over the bottom squared. So notice, I know I'm your teacher, but I was able to do that just by looking at it, by writing down the answer. So I want it to be clear, this is f prime g plus f g prime, and that is my other f prime. And that's your answer. So we are going to be done for today. I want you to take a minute, well, try to do this problem yourself and make sure that you get to the same place I did. Try to understand on your own how I was able to do all that. And also know that if you get comfortable doing all of these things the same way that I did, it's okay to go straight from f to f prime without showing any work.
When the
I forgot it, I'm sorry.
The subtraction
I forgot this term, my bad. No.
I was just confused.
Yeah, no, I forgot to write this. My F kind of got cut off. There you go. Derivative of the top times the bottom minus the top times the derivative of the bottom divided by the bottom squared. Anyway, we are done. I'm gonna press stop.